Hi guys, welcome to Math 100. Here we go with the very first day we're actually doing any math. This is section 2.1. We're skipping chapter 1, by the way, straight to chapter 2. 2.1 on sets, subsets, and Venn diagrams. All right, let's do this. So take a moment just to read the top paragraph to yourself. You can pause the video if you want to. We're talking about this huge math topic, sets, and it might be foreign to many of you, but don't worry, you'll get the hang of it. And if you haven't done so already, I really strongly recommend that you read the book. That's actually my expectation, that you're reading the book, especially for this first section, because this is going to set the stage for the rest of this chapter and also for just the rest of this class, really, to get a feel for how the book explains things in conjunction with what I provide to you guys. Okay, so here we go. What is a set? So if you look at our book technically will define a set as something that's undefined. Their point is that, there's certain words that are so fundamental that you have to just start with certain things that are understood. But that being said, we're going to use a working definition and say that a set is a collection of things. It's a collection of things. That's basically all it is. It's a collection of things that's well-defined. And what's well-defined? Well, we're about to define what well-defined means in a little bit. 1 second from now. Okay, first, let's talk about what an element is, though. An element is the individual things that belong to a set. So those are the components that make up a set. And it's well-defined if it's clear whether an element is in a set or not. When I say clear, it means you can say if it's in there or if it's not in there. So let me give you an example and a non-example. So an example would be NFL football players. That would be a set. Why is that a set? Well, because you could look at an individual and say they're either an NFL football player or they're not. Now, a non-example is the best NFL football players, and that's because this part best, that's subjective. If you look at a particular NFL player, you're not really sure, do they belong to the category of best or not? Okay, even though I just said that and I said what well-defined is, sometimes we can be a little loosey-goosey and let things sort of... We could really think of the best NFL football players as a set. It is a collection of things. It's just, strictly speaking, by the purest form of the definition, it wouldn't be considered a set just because of that ambiguity here with the word best. Okay, so what do we need to know? What did we talk about so far? Basically, a set is just a collection of things. And for it to be a true set, it should be well-defined. Okay, now let's talk about a notation. Notation is actually a super huge topic in math. In fact, when I was in grad school, I feel like that's the biggest thing I learned about was how to read math. And reading math has a lot to do with notation. When you study a language, you learn how to write the symbols, right? Same thing when you're learning math, which is really math is a language. So as you're learning math, we need to know what the notations are. Capital letters like capital A, for instance, represent sets. Lowercase letters, for instance, this little a, for instance, represent the elements. Okay, so big letters for sets, and then the components of those sets are little letters. This symbol right here, let me use a different color actually. This symbol right here means belongs to. So that means if I put it all together, this little a, that's an element of this set, capital A. Yeah, so that, and then, the next part says exactly what I just read. It says this right here that I just looked at means little a belongs to set big A. Okay, if this seems really weird to you, then just pause, rewatch that last, 30 seconds or so until you get the idea of what we just talked about. Okay, now next is a few common sets. Common sets include the natural numbers, the integers, the ratio numbers, or what do you call the quotient numbers, or I have the wrong word. What is it called? When you take a quotient, the word is eluding me. What is it? Rational numbers. I'm sorry, it took me so long. Rational numbers because they're ratios of each other, and then the whole numbers. So let's unpack those for a second. And then after I unpack those, we're going to actually just end this first video already. Okay, so what are those? So first of all, natural numbers. And we have this kind of fancy way. It's really a capital N, but we just add this extra line to make it distinguishable as the natural numbers. And it's the set of natural numbers, the most natural way that you learn numbers when you're a kid. You learn the natural numbers as the counting numbers, right? When you're first teaching your kids how to count, you start with 1, right? Unless you're a weirdo and you start with 0, but most people are not weirdos like that. Okay, so 1, 2, 3, 4, etc. And I think something we can do to indicate that it's gonna go on forever, we can just include these dots just like you would in English. Yeah. Okay, so that's n, the natural numbers. One step above that is z. Z for the integers. You notice I'm writing these things in this fancy curly bracket. Fancy curly brackets like that are used to indicate that we're talking about a set. So that's a set of integers. And what are integers? They're all the natural numbers, so 1, 2, 3, 4, etc., etc., etc. But also they're negatives. So I'm going to start by writing the dots to indicate that it can go on forever in that direction. -3, -2, -1, and then 0. So also including 0, and then 1, 2, and 3, and so forth forever into the right. Okay. So what are some examples of integers? These numbers for sure are all integers, the ones that I have written down there. -3, -2, -1, 0, 1, 2, 3. But also things like 4, 5, 6, 7, 8, 9, 10, 11, 12, 1 million, trillion, etc. And they're negatives. So -100, -1,000, -10,000, -100,000, etc. Those are all integers. By the way, if you're wondering why we use the letter Z for that, it comes from the German word for integer that starts with a Z. Okay, so those are the first two really common sets. Let's talk about a couple other ones. So the quotients, or the rationals, we call them. Okay, this is the rational numbers. And what are rational numbers? Those are just numbers that can be written as ratios. What's a ratio? It's just a fraction. So it's really anything, and you can write a set by describing it. So really you can say it's anything that can be written as a fraction. Or a ratio. Fraction is just another word for a ratio. Okay, there's a kind of strange way that we write the set of all rational numbers. And that's because if I try to make a list like this, it's really impossible because I'm for sure going to miss something if I try to make a list like that. And so we have like this really weird way of writing it. It's called set building notation. But to get there, I'm going to need to explain what that is. What is set builder notation? Okay, and for that, I'm going to come back in another video because it's kind of a big deal, kind of a big topic. So let's come back to that. Let's just leave Q as the set of rational numbers for now, and then later on I'll show you how to denote that specifically, or precisely, I should say. Okay, the last one is the whole numbers. And whole numbers are basically the same as the natural numbers. The only difference is we include 0 this time. So it's all the natural numbers plus 0 as well. So 0, 1, 2, 3, 4, and etc. onwards forever. Okay, let's stop this video here, and then we'll come back with the next definitions and start some questions off.